request Ignacio from JS Solar, Imco from Endurance, Steven from PI Berlin, and Tristan from Kiva PBL. So the today's topic is today's solar module testing framework is good enough to guarantee long-term reliability? And today we will stick to the manufacturing side of the reliability topic, and Michael will discuss tomorrow on the overall PV system in operation. So I think, let's take it from the title of the panel itself. So a question to all: is today's solar module testing framework is good enough to guarantee long-term reliability? Anyone can start answering.
I'll take that. I would say, like, we released this Raising the Bar white paper, and that was to address that the issue that just doing PQP testing alone is not sufficient. So I think with the PQP, we are finding, module issues and finding modules that don't have issues, but it's one thing to test, a pallet of modules and find that they're good, and then buy 200, 100, 500 megawatts of those modules and expect them to all perform like that. We're talking, it's getting into the millions of modules. You can't just take a PQP test report and say, okay, now my site is going to perform just like this report says. So that's why we're encouraging more batch testing and ongoing reliability monitoring to show that the manufacturing is consistent. I think PQP is sufficient in identifying, that the design and the bill of materials is reliable, but it doesn't answer a question about manufacturing consistency with batch-to-batch variability. And we're encouraging that batch testing and ongoing reliability testing to answer those questions.
And if I may, just to follow up on that, because I guess we're yes. singing from the same hymn sheet. And on that, the flip side of that is that even if, let's say, the quality assurance done during the manufacturing is sufficient and it's consistent, if you're selecting a module type that may have gone through the PQP test program or something similar in terms of extended reliability testing, if that module type doesn't have the same bill of materials that was tested, then you can't be sure on the material reliability. So that's just as important. So, and that's an issue that we certainly have, let's say, in day-to-day life here in Europe in terms of procurement, that we're not getting the commitment from the manufacturer that the same bill of materials is going to be used, that has gone through these extended reliability tests, clearly because of many very valid reasons in terms of pricing, in terms of availability of certain materials and sub-suppliers, et cetera. And the pressures are certainly on manufacturers. But again, if you don't have that bill of material consistency, then the test results that may be very positive may not be very useful in real life when those modules go into production.
I can add something on from the manufacturer point of view on those regard. I think we are fully aligned on that, right? Because there are like different things, because as we all have been explaining today, the technology is moving really fast, right? So we need to react and put in place all the tools that we have. I would say that our industry is really high technology industry, and we have the tools, we have the knowledge, and we are acting as fast as we can. But there is a pre-qualification of the new technologies, right? Or a check-ins of all the behavior of those new technology, and that should be done in a more overall, right? Or in a general point of view, like provide or checking several combinations of materials. But I agree with Steven here and also with Tristan that the check-ins of the exactly BOM that you will be using on your project, right? And do all this type of extended tests The challenge there is that these extended tests, they are taking time, right? And it's a challenge in terms of the organization of the project. When do you need to start the test? Because you need to do it like months before the starting the production. That for us represents a challenge also, because the BOM, blocking the BOM is not something really easy. So sometimes we need to play with the different components which are impacting over the results. But in general, we can manage, and all the manufacturers, especially in my case, we are willing to do it, and we are happy to be collaborating with all the players on those regards. So I think it's achievable. We are moving in the right directions, but of course, as everything in this world, it has challenges, right?
Imco, can you bring some material supplier perspective?
Yeah, of course, we're not a module manufacturer, and well, we noticed from as a backsheet supplier with the new IC standard for backsheet 62788 at least, I would say the part of developing the BOM is extensively covered. So I tend to agree also with Kristen and saying that where it's needed is much more the batch to batch quality control, and I would also say from a sustainability perspective, it would be very good to have something like a material passport connected to every module. So also at the end of life, you know exactly what is in, what value is there, but it can also be used as a quality control to see what is changing in the bill of material, because that indeed is often also although BOMs are not certified, encapsulants or backsheets or whatever are changed regularly, probably because of cost reasons. But yeah, that can also be a cause of failure, of course.
Okay. But still, some issues like UV degradation of TOPCon are surfacing recently. Now, of course, UV degradation is also part of PQP test. So question to Tristan and Steven. So was the UV degradation risk of TOPCon was already in your radar? And if yes, why it is becoming such a big topic now? So unlike in heterojunction, right from the beginning, they were aware. So there were a lot of developments from the materials and to have the UV blockers at the band bending. But, this TOPCon UV degradation is all of a sudden became a hot topic now. So what can you shed some more light on this?
Well, I think part of it is that we're releasing results both as Kiwa Pivel and other third parties are releasing results and starting to raise alarm. I would say in some of our initial UVID testing, a year and a half ago, maybe even earlier, we saw that TOPCon was relatively stable, but now we're seeing it's getting adopted, or it has been adopted by most manufacturers. And we saw in some earlier presentations, some manufacturers have different ways of controlling UVID versus others. And, when we've seen this before in other technologies like boron oxygen destabilization in PERC modules, or soldering issues with multi-bus bar modules when they were first released. As the industry moves to mass adoption, we see a wide range of results, and then forums like this and talking about the different ways different manufacturers control these issues, it gets better and better until all of the results, or most of the results, are good in our testing, and then we switch to a completely different technology and we start that again to get better and better. And it's an ongoing process. And I think right now we're in that with UVID for TOPCon. Some modules are doing well, other modules have room to improve. And I think, probably 2 years ago, 3 years ago, the early adopters of TOPCon had less UVID issues. And so when people would sample modules and do some UVID testing, it looked fine. But now as more people are doing TOPCon and there's different flavors of it, there's different propensity to UV issues. And I think that's what we're seeing in our test data, and we're raising that alarm, and that makes people more concerned about this and it being a hot issue. Stephen, you got anything to add to that?
No, I agree, and I think we can say we've had a similar experience with our testing of TopCon and our UV results. And just speaking to people in the industry as well, you hear, as Tristan said, there's different ways of going about optimizing TopCon cell technology, and I think some manufacturers of cells have gone into a direction trying to optimize the cost saving benefit and efficiency side of things. So maybe on the efficiency side, taking out UV blockers on the one hand, and on the other hand with the passivation layer trying to save costs in terms of getting it thinner and thinner. That all this leading to the propensity of being more sensitive to UV, whereas others that perhaps the early adopters were more conservative, we didn't see this kind of sensitivity in the market yet. So we're learning, and I think we're seeing just as quickly as we start to see this issue, we're starting to see manufacturers already take corrective actions and improve the technology.
Okay. So, Ignacio, companies like J Solar do several qualification tests, and you have in-house laboratories and this climatic chambers and several tests set up, before you launch a product. So, why UV degradation, for example, was not detected in the beginning, or can you shed some light on that?
Yes, sure. Well, yeah, I wouldn't say that it was not detected, right?
Okay.
What we saw, it's like a change in the trend, right? We were coming from an scenario on the PERC where it was really, let's say, stable and under control, and we found different values. If we said what we are doing, what we are launching a new technology, a new product, it's always working. Firstly, we work in the design, but we work with pilot lines, right? And those pilot lines, they are not using the final formula of the modules, right? Because in such moments we are testing. It's what Stephen, it's exactly what Stephen it's commenting, right? It's like you are changing the pattern on your cell, you are changing the different layers, and you obtain different results. Then, in our case, when we realized on that, we were like not trying to, reliability for us, it's going first. So we were not probably reaching the same efficiency that we could be able to reach by not sacrificing those values. And as I mentioned during my presentation, we were detecting higher values than the ones that we were detecting in PERC, because we were in a range of 2% or even 2.5%, even reaching in some samples 3%. Okay, but then we start to use different combinations of the BOM to reduce it. Nowadays we have in our common test on this regard, depending on the BOM. Okay, that's crucial. Depending on the formula that we are using, the encapsulants, they are playing a role as well, but we can output 2%. So it's something to keep an eye on that and to control before launching. Let's say, in our view, don't use something which is not mature or it's out of your control. We prefer to sacrifice performance and be in a worse position in those regards, but keeping reliability and these values.
Okay. So, probably a question to all. So what needs to be improved in terms of pre-product, product, and pre-shipment testing? In one word in each, for pre-product, the product and pre-shipment testing, what can be improved from the existing practices?
Yeah,
maybe Ignacio, you can start. Sorry, Imco, please.
Okay, so I would say, listening to the comments here, but also our experience, where we see that if we test TopCon, I always say that every TopCon cell is different at this moment. So the majority of TopCon which are being sold in the market today, and I know it will get better in time, but it sounds a bit like too immature to launch. So I think especially for pre-product launch, then there should be some kind of better control on the maturity level of these cells. And I'm not knowledgeable in that detail whether something is there already, but it sounds to me from experience that should be improved.
Ignacio, maybe?
Yeah, maybe to add something on those regards. Yes, pre-products. It's linked with the same explanation. We saw another example with the monofacial, right? In this case, with the backseat of the monofacial top cone, right? We all realize of a different behavior of those cells in the same encapsulation and backseat that we were using with PERC. We saw that, we detected. And then depending on the different players, well, in our case, for example, we are now, after 1 year, roughly 1 year of investigating and working with all the players of the backseat and encapsulation, and also making modifications over the cells, now we are in a good position and safe position to launch the monofacial. But yes, at the pre-product stage, we need to be clear, right? And not take risks that could be like damaging for all the industry and destroying the trust on us, right? On the reliability of the materials. Further than this, the rest of the process, products, pre-shipment, post-shipment, I would say that that's completely dynamic. And I think it's good, right? Because the different requirements are coming to the projects that have different requests, right? For me, pre-shipment, it should be a must, and post-shipment is depending on the situation of each project and how is the supply chain. But those part dynamic, and the pre-project product, sorry, it should be like from a responsible perspective.
Okay, I think, Ignacio, I have a follow-up question. All the testing costs money in terms of unseen cost pressure. What's doable for module makers, and what's different today compared to 2 years ago? Because right now we are in an era where the cost pressures are really, really high.
Well, that's interesting. I would say that nowadays we test even more than in the past. Okay, so which is something curious, right? Because now we are more tight in terms of cost, but the requirement it's higher, which on the other hand, it's good. Okay, from a technology perspective, that's fine. Nowadays, we are in position, or what we have done is to invest in our facilities and our capabilities to test, right? And the level of collaboration that we have with our customer on those regards, which are more and more demanding day by day, is that we need to be adapted to this market. And as said, right, we are comfortable on those situations because we prefer this approach on being safe and check it beforehand, and all the players are happy. Even in these cost times or reduced cost times, we are doing more tests than before, which is curious. Maybe our colleagues from Kiwa can confirm, but that's our feeling. Yeah.
and Steven and Tristan, are you also seeing as a trend in general in the market about this? Like, is it more?
I think more so not just the testing, but the overall quality assurance process. I think more and more investors and buyers are looking to apply this because the investments are so much higher. The scale of the projects are so much larger. Yes, module prices are going down, but the overall size of projects are increasing. And also on the other side there, the economics of projects are so much tighter and thinner, due to financing costs and lower electricity prices, etc., that any kind of lower performance issues or any kind of major serial defect issue or something like that can absolutely destroy a project. So we see more and more larger players going to apply the full module quality assurance process.
Yeah, I'd also say, echoing Silvana's presentation, sites are underperforming, and there's sites with broken glass modules in the thousands of broken modules. And I think these investors and developers, they're not getting out of the industry, but they're realizing that they need to increase their due diligence to ensure that their sites aren't affected by some of these issues that they're seeing in the field. And yeah, there's more money on the line, and they want to safeguard those investments. So doing, for example, the batch testing I referred to, doing regular damp heat testing, and doing far more regular mechanical load testing, they've realized we can't just get a letter, a tracker compatibility letter from the manufacturer based on one module and deploy 1 million modules on those same trackers and expect the results to be the same. That one module that was tested is not representative for the million that I'm mounting. So I think the industry is realizing they need to do more due diligence, and we're seeing that.
Okay. Okay, so Stephen, you know, in your pre-shipment inspection results slide, you showed that every inspection parameter performed relatively low. So that means you have a higher defects in 2023 compared to 2022. And if you look at the background, the major change is volumes have increased and price has reduced. So what do you think is the cause? You know, because you really showed every parameter has really increased.
Yeah, I mean, let's say there's been a lot of dynamics in the market over the last couple of years. And let's say price is yet maybe the result, but what was really the cause? Well, there's a heck of a lot more production out there, new you know, cell capacity, new module capacity was sprouting up in the last couple of years like crazy. And of course, all those factories, as you also saw in one of my slides, the variation in quality between the same manufacturer's module type at different factories, right? So that's normal. There's learning curves. There's new, you know, teams that need to be trained. There's, you know, new equipment that's being used that wasn't used before. All these kind of things add more and more variation that takes time to get it under control. And then you need to look at the US market's impact as well, right? And of course, we don't do just quality assurance in factories in China, but really all across Southeast Asia. And that's picked up, you know, due to all of the policy regulations happening in the US over the last couple of years. So that has an impact as well. And then as well, the domestic factories in the US that are starting to pick up, which we'll start to see in the 2024 results, because we're definitely seeing a really steep learning curve there.
Okay. Okay. So what do you think it would be for 2024? What do you expect?
Well,
Or what's
I mean,
your feel?
I think that's what I'm saying. Like, as soon as we start getting the data in from the US factories, I think it's probably going to make it look maybe a little bit worse. But at the same time, you know, those new factories across China have probably, you know, improved and gotten a little better. So hard to say what it's going to look like overall.
But whenever there is this production boom has been going on, you have already seen in the past. So this was your learning part of your learning curve.
No, well, I think with the production boom, again, it's new sites, right? And every new site is going to take time until, you know, the teams, the equipment, you know, start to really hit the same levels of quality. Maybe Ignacio can say something about that. You know, what they expect. You know, how long does it take for a factory to really get up to speed to, you know, the same performance of a factory that's been running for the last 5 years? I can imagine that there are challenges. And that there are learning curves in each of those new sites.
Yes, if you want me to answer this question, Stephen, yes, that's completely, I mean, that's natural, right? We are human beings and we need to learn. Obviously, we have like a standard processes and we are taking our quality control to the new sites and the new places. We are bringing the teams, the experienced teams to those places, right, to start the activity there and start the ramp up. But there are also something with the equipment, right? You know, the setup of the equipment is also taking time to find the right setup and so on. So obviously there are like months of and testing procedures and so on, but that's like something natural. We are reducing those times, but yes, that's something real. Yeah.
Okay.
I think
Tristan,
just to add, sorry, I think the difference is the scale. You know, we used to hear factories say, oh, we're not ready for PQP testing. We want to wait till our production is stable for another 6 months, for example. And in a 300 megawatt factory, you know, that 6 months is let's call it 100 megawatts, maybe even less because they're ramping up production or whatever. Now we're hearing that from like a 10 gigawatt factory. We're not ready for another 6 months. Our production isn't stable. We don't want to do third-party testing. Like, where are those 4 gigawatts going? Yeah. And, I think that's the concern, and probably why the pre-shipment inspection, the factory oversight, the batch testing, etc., all of that is increasingly important, as we mentioned earlier, due to this scale. We're not in this, few gigawatt industry anymore. We're approaching a terawatt very quickly. And if 50% of that production is during a ramp up phase of a factory, oh my God, that's a lot of modules that will need recycling before end of life.
Yeah. So, Tristan, let's also talk about the PVL's scorecard. In which parts the companies are performing well and where they don't. So, do you see some kind of a trend?
Well, I think we see a trend across, generalizing. We do multiple tests. We test multiple cell and module technologies. We have glass backsheet, glass, and multiple tests by multiple manufacturers. So it's somewhat difficult to like boil all that down to one trend. I think generally, though, we are seeing that reliability is improving. If you look at our thermal cycling or damp heat results or PID results, 10 years ago, the range of results was much higher. And that has slowly gotten better over time. It's certain that multi-bus bar modules are better, more reliable than 3-bus bar. And we're seeing, more reliable backsheets come on the market. Shout out to Endurance and other manufacturers making those, as well as, better encapsulants, etc. So I think as a general statement, module reliability, at least when it comes to PQP testing, has improved year on year. Now, that said, we still see that there's issues that we uncover. We're still seeing junction box failures are still a big thing in our testing. And it's incredible that like we still see lids falling off junction boxes. Like even just shipping them to us, we take them out of the pallet and a lid's fallen off. And, that's a failure before we even do anything. And, how is that still happening in 2024? We're also seeing that, as I mentioned in my presentation, an increase in the number of bubbles around the perimeter of modules. Like I mentioned in the presentation, that was an issue 10 years ago, and we solved it as an industry. So we did UV testing, it was part of the PQP for the first like 5 years, and it became the most boring test. We didn't see any issues in UV. So then we said, okay, let's focus on other issues. As soon as we remove it, a couple of years later, now there's all these UVID issues. So we learn our lessons as an industry, and then we change technology, or we try to, remove costs from the module, and now we have to relearn those lessons. So generally, reliability is performing, but or is improving, but we're still seeing that there's issues that we're uncovering on a regular basis.
Okay. Tristan, again, a question to you. With the move to TOPCon, the industry has been shifting more towards a glass. So, what are the specific tests you are doing for glass, and is this sufficient?
Yeah, I think we do see that we reported in the scorecard that on a lot of on some tests, glass is better. It's better for thermal cycling. It's protecting the cell better. We see it as better for damp heat. That's not to say we don't see glass backsheet bombs that are performing well in those tests. It's just to say that on average, glass performs better than glass backsheet. Where that's not the case is hail testing. As I mentioned in my presentation, if you're installing a 2.0 millimeter glass module in a hail region, that's a risk. And those hail regions aren't just in Texas. We saw hail earlier this year in Italy destroy a bunch of modules, and it's happening in an increasing number of places, extreme hail events. So that's something to be concerned about. And then in the mechanical durability, glass modules really protect the integrity of the cell. We don't see micro cracks in glass modules. Those are exceedingly rare. Like, we've tried to create cell cracks in glass modules, and we're unable to do it without breaking the glass. But that said, the glass isn't as strong, and we find there's higher prevalence of module breakage for 2.0 millimeter glass modules. So yeah, I would say the mechanical stress sequence and the hail stress sequence are really the focus for glass reliability. And I think those are sufficient in showing which modules are done well and which aren't. But again, as I keep saying, testing that couple modules in mechanical stress and 4 modules in hail stress, and then buying 1 million of those modules and expecting them to perform the same as what we saw in our testing is not recommended. That's not what we say is a good use of the PQP data.
Okay. Imco, you are a pioneer and originally a fully international company. Today you are focusing on the US market more or less exclusively, if I'm correct. And so, but I'm also hearing that there is a kind of considerable demand for backsheet based products from the US market. And so do you also see that? And if yes, can you explain why only US?
Well, I don't know why only US, but I mean, we do see a significant demand of backsheets in the US. I think there are a couple of reasons for that. First, let's say the incumbent module manufacturers, so who have been there before the IRA in the US, they were focusing on residential, so they're used to produce glass backsheet modules, or perhaps I should say they are not used to produce glass modules. And they now also switch to utility scale and just continue with making glass backsheet modules for that segment. Secondly, glass is quite expensive, not only as a selling price, but also for transporting it from Asia to US, especially with the current pricing. And yeah, there's for IRA, for domestic content, there's no glass manufacturing in US, so also that drives a bit towards glass backsheet modules in the US.
Okay. So I actually have prepared a lot of questions I want to talk, but I think we have very less time and we have exceeded our time limit. So I think I will have last 2 questions. So unfortunately, we don't have so much representation in today's conference from the heterojunction segment. In the presented test, especially Tristan, except for PID, TOPCon and PERC actually performed relatively better than heterojunction. So maybe starting from you, I would like to have everyone's opinion. Actually, what is lacking on HJT front in general, and how can we improve that?
I think what's lacking is they're just earlier in the learning curve. So we see manufacturers that have been doing HJT for years. For example, Panasonic, when they were still manufacturing, we used to test their modules and they were fantastic. They were very reliable. They had been doing it for, with Sanyo for 20 years, and we didn't see, reliability issues. Now we see more manufacturers, not as many as TOPCon, but some manufacturers move into the HJT space, and there's a lot to learn. It's a different module technology. As I mentioned in my presentation, the soldering is low temperature, and it's more susceptible to moisture and other degradation mechanisms. And we see that there's still, similar to Panasonic, there's manufacturers that can make a very reliable HJT module, and there's others that are still earlier in that learning curve and need to dial in their process a bit more to have a more reliable module. And I think that's the fundamental thing we're seeing in HJT.
Okay. Ingo, would you
plus,
like
I think the benefits that, sorry, just one thing. I just think that the benefits just aren't clear enough, right? Yeah, and maybe Ignacio can share their results, but just in terms of efficiency and performance, and then when you weigh that with the extra cost versus where TopCon is getting to in terms of efficiency, not sure that it's worth making that technology switch with starting over that learning curve again of mass production, for the industry, if that's the right move. So I guess we'll take the lead of, or we'll have to follow the lead of the large manufacturers like JA. But at the moment, I don't think we're seeing the overall benefit that can outweigh those other challenges.
Yes, definitely. I mean, from our point of view, it's fully agree with you. It's the maturity of the technology, right? What we have seen, of course, we have manufactured heterojaction and all these challenges that Tristan also mentioned, right? The low temperature, it's a challenge for us in the manufacturing stage. For example, a clear example, we were considering to use heterojaction with the small modules in residential, and the power output, it was sometimes even the same, right? So it was not enough trigger, not enough benefit to put a higher price, which is coming from a higher cost of the production. And the maturity of this technology is not yet as it should be. And the point is that the bridge, it's even now larger, right? In terms of the momentum that we have found of the evolution, the learning curve moving forward of the TopCon, it's now even farther than the heterojaction, right? Which is having less momentum, less investment, less research and development on that, because there are less interest, less commercial interest. So yeah, basically that's the explanation. I agree. Yeah.
And Imco, so how much it matters, the heterojunction, for you as a material supplier?
Well, it does matter. I mean, it's a potential new cell technology, and we want to sell our backsheet, so that means that we also need to adapt that to that kind of cells. But the difficulty with this cell technology being immature, and I mean, it's clearly less to a less extent for TopCon. If we, let's say, take 3 suppliers of heterojunction modules, and we let them test our backsheet, we get 3 different results. So it's clearly, yeah, I would say that the cell technology is not fully mature yet. And then that also makes it difficult for us as a material supplier, because what will be our target? I mean, we can start developing, normally that costs 1, 2, 3 years. Then if you come up with a solution for a heterojunction cell and the cell has changed, then so it's a bit of a, like, let's say now we are like waiting a bit to see how technology for heterojunction matures, and see whether it will get a market share or not.
Okay. So I think as a closing remark, from all, could you say, what is the best part of today's testing framework, and what is one aspect that is lacking to guarantee the long-lasting durability? Anyone can start.
I'll go first. I think, Silvana presented some very strong data on modules produced in 2019 that showed some real surprises, that, the degradation rates are higher. I think what's lacking is field data to prove degradation rates that manufacturers are claiming. 1% in the first year, that can be measured within a year, hopefully less with some accelerated testing. But looking at 0.4% degradation year on year for the next 30 years, we don't have data to support that as an industry. We don't have it as p-val. Some manufacturers say, oh, here's my PQP test report. That shows I'm going to degrade 0.4% per year. That is not what we say at Kiwa. So we don't have that, and the industry is moving very fast into new designs and changing cells and changing materials. And I think the PQP and ongoing reliability testing and batch testing and pre-shipment inspection is the best we have. But the big gap is that we don't have 30 years of field data on modules being sold in the hundreds of gigawatts today.
Yeah, couldn't agree more. Having actual field data, and I would have certainly liked to have more time to hear Silvana's explanation of those results. We're seeing it with this UV degradation phenomenon as well. We're starting to collect some data. I know PVAL is as well outdoors to really see the actual impact. We're sounding alarm bells, but we don't really know what the actual performance data is going to look like. So that's key. I think that's where we're seeing the biggest lack at the moment, because in terms of the standard testing, I think we've got the test sequences. There are multiple test programs out there that are really achieving the same kind of results. So I think we're quite solid there. And then just maybe a final word on, again, that BOM consistency and making sure that matches the test data. That's really, the main factor. If you're not doing that, then the test data isn't really that valuable.
Okay.
Yeah, maybe
yes, go ahead.
Sorry, no, please go ahead. Please.
I want to say in Dutch we say meten is weten. So having data, that's knowledge, and so I fully agree with the others that what I liked very much in the presentation I saw today, that it really gives a good insight in where the industry is at the moment. It's difficult because this industry is like a moving target, so you can build up data for 30 years, but then that's very old data after 30 years because you don't use that technology anymore. So we really need to find some balance there in making certain assumptions, of course. Yeah, that's it.
Yeah, I also agree. I mean, I would ask for, or I would claim for some kind of stability or longer periods for the stability of the technologies, right? Because we agree that we are not looking for 30 years data, right? That would be like ideal world. But even with the previous technology, the PERC technology, I would say that it was really well known, right? And it was really the market trust on that, right? And we have field data enough to be safe on that. So I hope that we can lead the same with the N-type, and hopefully the technology is not changing as quickly, right? And maybe now that we are reaching really a competitive cost for it, maybe it lasts for more time, right? But yes, well, from a scientific point of view, the amount of data, it would be like crucial to be really sure of that. Yeah.
Cool. I think that's a very nice remark. Data is key, but also, we cannot really have 30 years data. That's really nice. So a little complementing, conflicting closing remarks. So I would like to thank everyone, Stephen, Tristan, Imco, and Ignacio. Thank you very much for your time and giving this valuable insights for our panel. So soon I would like to close our conference. Before I do that, I would once again like to thank our sponsors. Longi and JS Solar are our diamond sponsors, and Astro Energy gold sponsor, JTPV our silver sponsor, Hansa First and GCL are bronze, and A Solar and Endurance are the silicon sponsors. So I also would like to remind you that this is not all. So as I mentioned in the beginning, this is a 2 days event. So we have also an event, the second part of our reliability PV module design conference that is going to be held tomorrow. But please note that unlike today, it starts at 10 CET. And as I said in the beginning, so we also have a similar kind of a structure. We have research Fraunhofer Institute representing the research side. So we have Longji, GCL, and A Solar representing the manufacturing side, and Hanzo First giving the inputs from the material side. And like today, we will also have a panel, probably a little longer panel, and probably you will learn more from the experts deep. So, but Michael will moderate the panel tomorrow. And then, we would like to once again remind you that TaiyangNews is all about solar. We have several market surveys, reports, and technology articles. So recently, we have also launched a market survey on trackers. Before that, we made a report on top solar modules. So please stay tuned for our latest reports. I think soon we will also publish another report in the coming days. So thank you very much for staying longer, and have a nice day, evening, or enjoy your rest of the day. Bye-bye.